Hey, how you doing? This is going to be just I'll try and make it as short as possible. Just showing some islands and big ships, or well, big boats, at a distance of up to 18 miles from my location. So my viewer height is 74 feet. The globe's geometric horizon prediction should be 10.53 miles. Okay. I have a reason for showing these things. I know people will say, well, we've seen all these things before. You did, and I did back in 2015 and 2016. But something has changed since then. Okay, I'm just going to show the location. I was here, 74 feet here. That was my elevation. You can see down here at the bottom, 74 feet. Um, it's my location is Dunmore East. You can see it over here. I'm just going to scroll out. You can see this Dunmore East in County Waterford. It's the harbour, Dunmore East, County Waterford. And I'm just going to play the observations. I'll play this one first, and this is going to show a lot of stuff. At a distance, and I have a reason for playing it. And then it's going to show two boats. Then I'm going to show another short video with those two boats again, and another small thing in between. So I'll try and it's going to be jumpy and shaky. There was a lot of wind, so I'll try and stop it and give an explanation. All right, this is jumping around a bit. Okay, I'll just pause there. Okay, over here is about 17.5 or 18 miles away from me, this location here. This is County Wexford. This is Helvick area, Helvick Head. This is a fishing area over in County Wexford. I'm in County Waterford. And in between here is, that's about 4 or 5 miles away from me here. This is also County Wexford, and it's leading out to a lighthouse called Hook Lighthouse, Hook Head Lighthouse. So I'm just going to leave it play. There'll be some things I'll have to pause it at. I'm just showing back this way. Actually, something I want to show. Actually, this here is to here is 4 or 5 miles away from me. But this here, right, although it's not noticeable, this stretch of water is actually over 13 miles. So you can see how compression can make something look like that. Looks like it's just maybe a mile away due to compression. It just looks like a mile away, but when you see later, when I zoom out, it's not a mile away. It's actually 13 miles across there, over 13 miles I think. And this is about 4 or 5 miles here, and that's over 13 miles. So it looks like it's just over there. So let's came back this way, and I changed my. It's hard when you're zooming to see exactly what you're looking at. You know. There we are again, and this is Helvick Head out here. Sorry, it's yeah, I get it. Right, that'll do. You can see that's Helvick Head out there. That's 17.6 or 18 point something miles away from me, from where I am. And I'll tell you at the end of tell you all at the end of the video why I'm showing this. There are some wind turbines. Let's go back to now wind turbines, and they're I think 19 miles from me. And yeah, their bases are actually, and I'm wondering about this with wind turbines. Their bases, I looked at supposedly, according to what I find, that their bases are set below sea level. Now I've seen often observations. Now I haven't fully checked that, but their bases are set below sea level. Now they are a bit of a distance from me, but what's interesting is would be that if a lot of wind farms like that were set with their bases below sea level, to get the highest winds that would probably be at a certain height above the water. I actually have a relative of mine who works with him, and I might ask him. But it's worth checking out because I've seen a lot of globe observations using wind turbines as globe proofs, with an incoming tide and whatever else. But if their bases are set below water, below the sea level, then that would account for a lot of things. Because I'm seeing other things here. What I just showed there a second ago is this here. This is almost exactly the same distance away. It might actually be the same distance away over here, this Helvig Head. And yet, on the wind turbines, about here, let's come past a bit. Let's go back. We see him again. Any minute now. We have to get up. There you go. You can see that the bases aren't. Now I know they may not have a high base anyway, but the bases aren't immediately visible. Now I'll keep on going over here. Sorry for the blurriness. It was windy, and any bit of wind at all affects my camera. Now this point here is just over 17 miles away, or 17.6 or 17.7 miles from me. Maybe a little bit more. This point here. This is the start of what's known as Little Saltee. These are the Saltee Islands. And you can see that you're seeing all the shoreline, and this is not just once off. I've several videos of this taken at different days, at all different times at different days. I don't watch the tides, I don't follow, I don't go out there at a particular tide, a low tide or a high tide. I don't do any of that. I just go out there early in the morning, later in the morning, during the day, late in the evening, early in the evening. Just go any time when there's light and I have a chance to go. So I've done this, and I keep getting, although sometimes I will say the islands can look bigger, and sometimes they can look compressed, which backs up compression as being a real thing, because a lot of people just on the globe side don't want to believe that. But the shoreline is always visible. Always, I can always see the shoreline. And they're an average of 17 miles away from me. The two islands are an average distance of about 16.5, 17 miles from me. And as Metabunk said earlier, the Globe Earth's predicted geometric horizon should have started at 10.5 miles for a 74-foot observation height. So I'm just going to go back there, just give you a better look at this island. You can see the shoreline there. As I said, it's a little bit jumpy, and I'll come back to it. Maybe I do or don't, or maybe it's in a different video as I come back to it. As I have ones I just exclusively did just for this, but you can see that it's pretty clear. Even a hazy kind of a day, you can still see it very clearly, and this is in all of them. Let's go back to the touch, and we get to the boats. Then, okay, this is Greater Saltee or Bigger Saltee Island, and as you can see, you're seeing the shoreline there. You know, you're seeing what's coming down to the actual shoreline. This would be probably maybe a 50-foot area of cliff coming down, or something like that. And there's some areas there you can see it's actually the shore. You know, they're at a big distance from me. And as I said earlier in the video, people are going to say, why are you showing us these things? We've seen all this before. Yes, but something is different now from 2015, 2016. I'll explain that at the end. So this here, at this part of the island here, at this section here, this is 16 miles, I think, exactly from me up here, because it's off of it. Whereas the other island is over 17 miles at the opposite end of the left side of the other island is over 17 miles, almost 18 miles from me. And I come across, I notice. I'd like to be able to skip through it, but I don't want to miss anything. I'll get to the boats now in a minute, but one other thing. Now, there's rocks here. I think these are what's known as Bohr rocks. I think they're called the Bohr rocks. They are almost 33 kilometers from me. So that's 18.5 or 19 miles, or maybe more, or something like that. 19 miles, I think. So that's a good distance to see that. Considering that's 8.5, let's just say 8.5 miles past where the globe, Earth's supposed geometric horizon, should have started. And we're seeing that, which means that the horizon is definitely stretching past the this island here and the other island. If we're seeing those rocks here, there we are again. If we're seeing those rocks, that means that the horizon has to be going past it, because I know it's compressed, but we're seeing them. So we shouldn't be able to see them at all at that distance. If we were on a globe, obviously we're not. Then we'll get to the boats. And this is not something that is a once off. I can get these observations all the time, and I can go on different days. And sometimes the weather conditions is a bit worse than others, but in general, it's always pretty good. Even on, what I mean is, it's always pretty good, as in I can always see where I'm looking, unless there's a rain or something like that stops me. I can always see where I want to see. So there's the first ship. It's called the Expansa. Now, the Expansa, that's pretty good. Let's see if I can make it better. You can see there's the bottom of the ship, and here is the bow. Okay, that's the stern. There's the bow, and as you can see, you can see this part here that comes out. I don't know. It's for stability in the water, I think, and I think they have a navigation unit in there. I can't remember the reason for it, but you can see where it should curve back in like that, as like a thumb type thing sticks out there, and you can see it coming down to that, and you can see the stern of the ship coming down and coming in. Like, you can see the ship on the water. Like, there's no way that ship has gone over any horizon. There it is, right there. The only time it gets fuzzy is when, and I'm doing this by hand, because there was no point where I wasn't trying to use a tripod. There was too many people around trying to set up a tripod. So I'm just holding it by hand. So there's a ship, like, right there, 18 miles away, I think it is, or 17, 18, something like that. I come across now to the next ship. That last ship is called the Expansa, and the next ship is called, when we get to it, coming back to it there now, get a clearer photo of it. This is called, no, that's better. This is called the Thun Globe. It's called THUNGLOBE. The Thun Globe. This is what the name of this ship is. I don't know where the name comes from. The Thun part sounds Thai to me, but I don't know what the actual origin of the ship is. But it's called the Thun Globe, and that is, I think, almost an equal distance from the other one. It's not as big as the Expansa, but it's an equal distance from me. So there you go again. You can see at the back of the ship here, you can see this. You can see like the round of the stern coming down to the water, and you can see it at the bow. It comes down and it comes out, like the way they're built. You can see here, this part here that comes around. My memory on it is I used to have details on it. Now I can't remember. This part here that comes out like that. So that ship has not gone over any globe horizon, So I'm moving on a little bit. I don't need to spend too long. I just tried to get it stable on it, just to show that it was doing what I wanted it to do. I'm just going to start zooming out now, I think. You can see how far away it is. It'll give you some idea. Now, there's your globe for you. Now, I turned off the, I'm just going to show here, I turned off the record button before I was going to show, this is when it was created. 7:36 is when the recording started on this, where is it, on this video, and this video was 4 minutes 19 long. So this went into 7:40. So I turned off the record and I forgot that I hadn't shown the phone. So, and I have this on my phone, it's in 24-hour format. This is not, it's in 12-hour format. So this here, it's hard to see it because it's right behind it. It's 28.7 kilometers to the Expanse. Here's what it is, and it's 1943. So it was within 2 minutes I got this within 2 minutes of doing the recording. And I'm just going to move on, and it shows the latitude and longitude, it's there. And I'm just going to move on. The Toon Globe, 27.8 kilometers. And I'm going to show latitude and longitude. Okay, so you have that detail. Now I'm just going to show this, which is showing those ships again, and this time, but I just want to show them a second time. This is not the same recording, this is a separate one I did. I think I did this from a lower elevation actually, but it don't really matter. But this is like slightly even better conditions. You can see, I'm just gonna go back there. You can see how clear it is, and then you can really see here that the part here on the bow starting to stick out of the water. You can clearly see here. I don't even need to take a photograph of them and zoom in. Like, I mean, you can clearly see that the stern of the ship is above the water, which means it's not going over and it's not about to fall over any globe horizon. Now, actually I'll start here. The reason why I'm showing these things, and it's not just because I decided to do observations. I never had an interest in photography ever in my life. Never had a camera up to about 3 weeks ago. The reason I'm showing these things is because back in 2015, 2016, when we were showing these things, when the flat earthers were showing this to the world, these kind of things to the world, there was all these arguments happened in between that with refraction and all kinds of nonsense went on. But now in 2020 we know better, and we've gone through all those arguments and we've disproved them, to the point where the globe side has to come up with ridiculous arguments to try and support their claims. They're absolutely gone into absolute ridiculousness, but they cannot explain this. This is not refraction. I can bring anyone from the globe side to this place, and even in bad weather, they'll be able to see 16 miles, if not 18, 19 miles to an object. I can show them exactly where it is. I can bring them there. They can go there themselves. I go out there at all different times of the day, anytime there's light, and I don't pick a time. I don't watch the tides. Don't care what way the tides are. I go out and I do the observation. And I actually got 2 black swans last night, but unfortunately I had my light on my camera up too high, so they didn't come out right at a distance, so I had to delete them. So I have to get them again. Of 2 boats that with the horizon behind them at a distance, way beyond what the horizon or what the globe's geometric prediction is. We're after going through so many arguments, I'm going to leave this play on, with the globe side since 2015, 2016. Now they cannot deal with these type of things. There is no explanation as far as the globe goes for this. There's the Toon Globe ship. There's no explanation for it. All they can say is refraction, which means they have to prove that it's a 7/6 refraction that's happening. 7/6, or which is just a mathematical refraction based on a radius value. There's no physical demonstration of 7/6 other than the assertion that it's real. Now, the other problem they have is they have to prove that the horizon consistently dips below what would be a direct horizontal from the beach. Does the horizon from standing on the beach, or from this height where the horizon is now, can the horizon at any point dip consistently below the horizontal from the beach? How does it do that? All the stuff about horizon dip. If I'm 74 feet above sea level, then I'm 74 feet above the horizon. But if I go down to the beach and I look out across the water and I see an horizon, will that horizon ever dip below mean sea level or basic sea level at that point? Will it ever dip below that? Will the horizon go down It never goes down. There is horizon dips from high elevations and from airplanes and all these kind of things. Never argued against it. It's total sense that there's going to be. But when does the horizon go below mean sea level? When does it do that? When does the horizon ever do that? Where is there proof of 7/6R? How can you explain this, which is the bones of about 8 miles past what would be predicted by the globe Earth predictions, mathematical predictions for its horizon? The horizon is way past, 8 miles past where it would be according to globe predictions. Then you have a ship on top of it that's obviously there. Where is the 7/6R proof? Where's the proof that the horizon goes below mean sea level? That's why these kind of things now in 2020, we can look at them with different eyes than we could in 2015, 5 years later, because we've gone through all those arguments and we know what they can't prove. There's angular size change. Look at the difference. It's gone into it's nothing. And I guarantee without the camera, I can barely see that, even with my own eyes. So I'm just going to show here the just the distances to them. They're slightly closer, I think, here by a kilometre or so. They're slightly closer this time around. Expansa. What distance? Let me see it now. 27.4. So there's 1 kilometre closer to Expansa. There you go. And now I show the Toon Globe. Toon Globe received 1 minute ago. So I'm just showing you how the information is right up to the same time, 26 kilometres. So this is a little bit closer. But there's still, you're talking 17 miles. There is no explanation. The globe can't do anything about that. These type of things. Where is the explanation for this? After 5 years, there was no explanation for this. 5 years ago, for 3-4 years after that, all this argument about refraction and this, that, and the other thing. There's no proof. They can not prove that refraction can cause that. Where is the proof that the horizon goes below mean sea level consistently? When we go higher, the dip to the horizon, should go, like the dip angle should go below horizontal sea level, but it never does. If you're 6 miles up in an airplane, if you're 38,000 feet high up in an airplane, your dip to the horizon with clarity, your dip to the horizon will only be a dip angle to horizontal at sea level, at that where you're looking. That's all it'll be. It'll never be below that. It should be like the dip angle from an airplane. If we were on a globe Earth with a radius of 3,959 miles, the dip angle should be way more ridiculous than that. But nobody can prove, and I've asked, and I put it out now for anyone from the globe side to prove that they can consistently show a dip angle to the horizon going below horizontal mean sea level. They can't show that angle going down further than horizontal. They can't bring it below horizontal. They can't do it. That's why I'm showing these kind of things. Is that now they're there again 5 years later, the same type of observations, and still no answer for them. We always find the answer to the globe Earth's observations, and I wouldn't mind I haven't seen anything like in my past few weeks of doing observations. I haven't seen anything like what the globe proponents put forward. I haven't seen any of these things where the water is welling up in front, making this big obstruction. Then again, I'm not living in places like Hawaii and Australia where you get that happening because of shoaling. But I don't see that. There's no proof of this refraction 7/6R. There's no proof of the radius. And there's no proof that mean sea level, or that the horizon dips down below mean sea level, down below the horizontal. You know, this shape is really there. That's the way it is. Thanks.